Hello students, this is Suman Sharma from sinidih. This is the second video for class 10. In this video, we will study about type of electricity and electric potential. First of all, we will learn something about electricity. So, electricity is the electrical energy and that electrical energy is a form of energy resulting from the presence of charged particle. So, electricity is simply the transmission of electrical energy through the charged particle. This is the simple statement for electricity. Now, electricity can exist as static electricity and current electricity. Here the word suggests that static electricity means when the charges are at rest, or the current electricity is also known as dynamic electricity, in which the charges are in motion. Now, in the next slide, we will define the static electricity. As students, written here that in static electricity, the electric charges remains at rest or stationary, they do not move. So, static electricity builds off electric charges on the surface. This is the case of static electricity. Means the electric charges builds up on the surface of the material. That static electricity is caused by rubbing together the two different materials where electrons move from one material to another and accumulate on the surface. As you can see in this image that here are the two materials, one is the balloon and another is the hair. When the balloon is rubbed against hair, then the electron or the charged particle transfer from the hair to the balloon, and that charged particle is accumulate on the surface of the balloon. That is the static charge. And we know that when the two oppositely charged particles come near each other, then there is electrostatic attraction between them. And you know it very well because it is one of the properties of the charges, that the unlike charges attract each other. Now, here is the another example for static electricity is that when the balloon is rubbed against any surface, then the balloon is electrically charged. And when that electrically charged balloon is put near the small pieces of paper, then that balloon attracts the small pieces of paper, which is one of the phenomena of static electricity. Now students, there is some natural phenomenon which is also an example of static electricity. You know that if the difference in electrical charges between the two objects builds up enough, here the negative charges and positive charges. So, if the difference in electrical charges between the two objects builds up enough, then the electron can jump across the gap between the two surfaces and it creating a spark which just look like this. And that spark is known as lightning, which is one of the example of static electricity and it is a natural phenomenon. So all these are the example of static electricity. You can write it. Now in the next slide we will study about the current electricity. Now students, in current electricity, as you can see that there is a cell and the arrow indicates the direction of current. And as it is written here that the electric charges are in motion and produces electric current. So current electricity is the flow of electric charges through the wire. It is not at rest. It is not accumulated at the surface, but it is flowing through the wire. And the current electricity is generally used in our home. Now to understand the current electricity clearly, firstly we have to understand the term potential or potential difference. Now student, to explain the term potential, let's have some analogy. If we take an analogy of air current or the flow of air, and I asked you that why do air flow, then you simply answer that it is due to the air pressure difference. Air current or the flow of air, it is due to the air pressure difference. And this shows that the air flows from high pressure to low pressure. And if I ask you that how does heat flow, then you simply answer that the heat flows from high temperature to low temperature, or heat flows due to the temperature difference. It is due to the temperature difference. So student, as air flows due to air pressure difference, heat flows due to temperature difference, in the same manner the charges also flows some sort of differences, and that difference is called potential. You have to remember it, that as air current flows due to the air pressure difference, heat flows due to the temperature difference, similarly the charges flows due to the potential difference. Now to understand this potential or potential difference clearly, suppose that I have taken an example. Okay. Suppose that there is a student here. Suppose that there is a student here. And the place is infinity. And a charge Q is kept here, and the student name is Rohan. Now there is a point A here. Now this student, what does the Rohan has to do? Rohan has to kept this charge, bring from this infinity place to the particular point A. If Rohan bring the charge Q from infinity to the particular point A, he does some work. Of course he will do some work. Then in doing this work, Rohan must have spent some energy. And students, you know that according to law of conservation of energy, the energy neither be created nor be destroyed. So the amount of energy that Rohan spent, where does that amount of energy go? That amount of energy gets stored inside this charge. So when Rohan brings this charge from infinity to the point A, whatever amount of energy he is spent in bringing this charge from infinity to the point A, now the charge is at point A and some amount of energy Rohan has to spend. That amount of energy which is stored inside this charge is at place A, and that amount of energy is called the electric potential. Electric potential of the particular point A, that is the potential at point A is denoted by the letter VA. Now there is some other student already present here, and he just kicked off this charge, and this charge reached to again infinity, and he said to Rohan that go and again take that charge from infinity. Then again Rohan has to go from point A to the infinity, and again he has to bring this charge Q from infinity, and he tries to reach to point A. Now, in all this journey, Rohan is very tired because he already spent a lot of energy. So, in the second case, when he tries to bring this charge Q from the infinity place, he spends some amount of energy and reached to point B. Because he is very tired, he doesn't have that much amount of energy, so he could reach to point A. So, when the charge is bringing from infinity to the particular point B, he again does some work, and for doing this, he again spends some energy. So, when the charge is at point B, then what amount of energy he has spent in bringing the charge from infinity to the particular point B, that amount of energy is called the potential of point B, which is denoted by the letter VB. Now we have 2 points at a point A and B. We have to find the potential difference. Students, pay your attention that when the charged particle is brought from infinity to a particular point, then the amount of energy spent in bringing the charged particle from infinity to the particular point A is the electric potential of that particular point. And when the charged particle is bringing from one point to the another point, then this is the potential difference between the 2 points. It means, suppose that if at point A the potential is 10 volt and at point B the potential is 7 volt, and we have to calculate the potential difference between the two, then 3 will be the potential difference between the 2 points. Okay, now if we have to define the potential difference, then the potential difference can be defined in the same manner as electric potential, that you can see in the next slide. That in bringing the unit positive charge from one point to another point, the amount of energy spent or the amount of work is done is called the potential difference between the 2 points. Now, for the electric potential, it is denoted by the letter capital V, and the formula is the amount of work done or the energy spent by bringing the amount of charge from infinity to a particular point A or B. Now, if we have to define the potential difference or the formula of potential difference, then the formula of electric potential and the potential difference is almost same. So, if we have 2 points A and B, and we have to find the potential difference, then we can write that VA minus VB, which is potential difference, and the amount of work done in moving the unit positive charge from one point to another. That means it becomes work done at a point A and work done at a point B by charged particle. So, if we calculate the calculation, if we do the calculation, then we can use this or either this. Now, the formula becomes that potential difference is equal to work done by quantity of charge transferred or work done by charge. Now, it can also be written in the symbol that V is equal to work done by. We know that the SI unit of work done is equal to joule, and SI unit of coulomb, SI unit of charge is coulomb. So, the SI unit for the potential difference is joule per coulomb. But the SI unit for the potential difference is volt, after the name of Italian physicist Alessandro Volta. In the honor of him, the SI unit of potential difference is also volt. So, we can write that volt is equal to joule per coulomb. This is one of the relations between the volt, joule and coulomb. Now, students, in the next slide, we have to study about the 1 volt, or we have to define 1 volt. It is very simple, and 1 volt is defined as if 1 joule of work is done in moving 1 coulomb of electric charge from one point to another point. As you can see that it is also written here that 1 volt is equal to 1 joule by 1 coulomb. Now, the potential difference is measured by means of an instrument called voltmeter. Voltmeter is an instrument which is used to measure the voltage or the potential difference. Voltage is another name for the potential. Now, the most important point you have to remember that a voltmeter has high resistance, and the second most important point is that a voltmeter is always connected parallel across the point between which the potential difference is to be measured. As you can see that we have connected the voltmeter in parallel. Now, in the next slide, there is a concept map. In the concept map, there is electric potential, and electric potential is a scalar quantity. As it is a scalar quantity, so it is added algebraically, and this is the definition for the electric potential which you already know, and this is the formula for electric potential. You have to remember it. SI unit of electric potential is joule per coulomb, and it is measured by the instrument voltmeter. And how does it connected? It is connected in parallel. And for a positively charged particle, it is positive, and for a negatively charged particle, it is negative. This is the concept map for electric potential. You have to memorize it for your convenience. Now, in the next slide, there is a numerical which is very simple. In the numerical, it is given that how much energy is given. You have to find energy. To each coulomb means Q is equal to 1 coulomb. Each coulomb of charge passing through a 6 volt of battery means V is given 6 volt. Now, you know the formula, potential difference is equal to work done by time. That means V is equal to work done by coulomb. Now, that work done must be equal to the spent energy is equal to Q. That means V is equal to E by Q. So you have to find the energy. So use this formula, and energy is equal to V into Q. You can put the value of potential and charge. You will get the answer. And you have to put the SI unit of energy because you are calculating energy. Now in the next slide, there are some questions for all of you which is your homework. First, by what other name is the unit joule per coulomb? Which is very simple, that is volt. Second, what is meant by saying that the electric potential at a point is 1 volt? You already know the definition of 1 volt in the previous slide. Now, how much work is done when 1 coulomb of charge, that is Q is equal to 1 coulomb, move against a potential difference of 1 volt. V is equal to 1 volt. So again you have to find how much work. You know that formula is potential is equal to work done by charge. You have to use this formula and you will calculate work done. And you have to put the SI unit for work done. What is the SI unit for potential difference? You can write volt, and you can also write joule per coulomb. Now, name the device that helps to measure the potential difference across the conductor. And that device, that instrument is voltmeter. Last, how much energy is transferred by a 12 volt power supply? It means voltage is given 12 volt. To each coulomb of charge, Q is equal to 1 coulomb. Here, each coulomb, that is 1 coulomb of charge, it will move around a circuit. How much energy you have to find energy? So, you know the formula that potential is equal to work done by charge, and that work done is equal to energy by charge. So, potential is equal to energy by charge, and you have to use this formula and you will get the answer for your question. So, students, solve all these questions which are very simple, and that's enough for today. Thank you.